Hello, hello, hello. Hi, John. How are you?
You're good, thanks. Yourself, Mustafa?
I'm doing good, and people are liking our podcast. I think we are meeting third or fourth time in different
Yep.
podcasts. There was
Mhm.
one time with you, and then couple of time on panel discussion. And
Absolutely.
yeah, people like it that most of my audience either are from vendor world or product world.
Yeah.
Hardly anyone from sales.
Right.
So my guest talk, they don't talk sales, they talk something which you can implement, which can generate a value, right? So I
Real,
think,
make it real, right?
yeah, we make it real, yes. So I think it's a great, right? And today's session is very near to my heart as well. It's graph, and everybody is going toward graphs, and then agentic AI, and
Yeah.
how agentic AI work and take advantage of this graph concept. That is where I got a little bit confused because initially I thought your product is working on graphs. Then I realized it is more over a agentic AI solution. Then I realized, yes, your agentic AI solution follows graph methodology. So today we will be discussing all those things. So again, just a quick intro yourself and just bring this dog innovation as well from your angle, just for our audience.
Sure. Thanks, Mustafa. Yes, so my name's Jon Cooke. I am founder of a company called Dataception. We've been around about 7 or 8 years. And the interesting thing about data object graphs or graphs generally is I always get brought in because my experience, I've been in data in like 20, 30 years. I've also done enterprise architecture. I did enterprise messaging, service oriented architecture back in 20, 25 years ago. I've also been involved in startups and products and launch products. And I've also done a lot of AI. I did my first Gen AI back in whenever it was, I was at 2016 now. So that was before Transformers were there. And the whole kind of mission statement and the whole kind of problem space I see is trying to really bring all those things together to actually give business outcomes. Fundamentally, I always get brought in to do some technical kind of pieces. Can you build this architecture? Can you build this? Can you build this technology? And that's like I always start asking business questions. How does this actually going to work from a business perspective? What's the outcome? What's the And sometimes I get even asked what the cost is and what the value is and that kind of stuff. So with a lot of talk around there, especially on LinkedIn and other places in the database around technology, data mesh, data contracts, data fabrics. These are all kind of technology solutions. But what I'm trying to do is actually come together, bring it all together as an end-to-end business outcome where I actually start modeling business processes because that's ultimately what I do. And obviously the graph is a great candidate for that. AI is also advancing the conversation from pure technology into much more business oriented outcomes. I mean, agentic is exactly the same, right? I want to do an agent to do X, Y, and Z, to do a marketing campaign, to book a ticket, or to do some business process. So I feel like the time is right really to have these sort of conversations, which 5 years ago was very hard to, but now it's actually much easier to. But it requires a few pieces brought together, and those are the kind of that's where the kind of the dog and the whole kind of AI and agentic AI has come into the piece.
Awesome, awesome. I hope people is able to are able to digest as much as you just pour it out. Okay, now this is great, right? You are absolutely right that 5 years back, people were not still looking into federated approach. I think the moment people came out of centralized approach, that is where people wanted to have small products. When they call it small products, then they need it very quick. And we all know when it is quick, it has to be agile. When it has to be agile, it has to be automated. And one team cannot end up having on the fly data products and do this and that, do decisions on the fly based on yeah, different criteria X and Y. That is where graphs comes into picture. And like even couple of years back, if I say in 2023 and back there, when taxonomies and ontologies, or especially Jan AI was not there, yeah, Jan AI. The moment Jan AI came in, people started learning this taxonomies and ontologies. And when they start using graph DBs, that is where they end up understanding what graphs are. And I personally feel that is where things started changing. And people started thinking what graphs are. And suddenly people started working on graph theories. And when they start working in graph theory, that is where I personally feel agentic AI come into picture. So agentic AI can talk and do a lot of stuff. So tell us, let's go. This session is very
Sure.
specific to go into detail of what
Yeah.
dogs are
Yeah.
and how. Okay, first tell me how you come up with this. Like you want to do this.
Sure. So it's interesting you talk about graphs being a new thing. It's if you go back 20 years ago, 25 years ago, around the turn of the millennium, actually, there's a thing called business process execution language, which was actually a way and business process monitoring and business activity monitoring. These are all attempts to actually describe a business process in technology terms, and they're all using graphs. Funnily enough, so they basically use that steps.
Yeah, it
Yeah.
becomes famous. What I meant is it becomes famous after Gen AI.
Yeah, indeed. So we did that, and we used to call, I used to call those execution graphs, and then they sort of morphed into kind of processing models like Spark, and you get the rise of the directed acyclic graph, which was a processing model. So I take a data set, I do a transformation of it, I do another transformation, and I put it out to an output. That's a graph. That's an execution graph. What you're talking about is kind of the rise of sort of what I call data graphs, and then knowledge graphs, semantic graphs, taxonomy. How can I describe things in a semantic way using a graph? But they're fundamentally graphs with data on the nodes, and they have relationships as the vertices at the edges of the vertices. So you've had these two kind of graph models, as you say, in the last 3 or 4 5 years. Semantic graphs, labeled data graphs have really become popular, but the execution graphs have been embedded into processing models for various technologies. Also, interestingly enough, a third part is really where you look at object-oriented systems. And the thing that underpins an object-oriented platform, I mean, C++ had it, Java, Smalltalk, there's a range of different ones, is basically what's called an object graph, where you actually, if you write code, then you have an object with a bunch of data on it, a bunch of methods and a bunch of data on it. It gets described by the compiler as an object graph. So I've got this class that references this class, that references this class, and each one of those classes has, let's say, functions on it or methods. It has also data on it, data attributes. So the object graph has been around for a while. I mean, I was doing object-oriented data programming back in my university days, back in 1990. So that's been around a long time. So you have these kind of three graphs, and I call the object graph what I call a hybrid graph, where you can actually execute, you can traverse, you can execute methods, and you can execute, but you also get data as well at each of the nodes. So fundamentally, I've got a customer can execute the cost of the number of orders for that customer, for instance. So I've called the customer class and it say, give me the number of orders for that customer, and it would execute the logic inside of it. This is something that doesn't really exist in the data world. What you get is a lot of both those, the execution side and the data side. You get the semantic, very much the knowledge graph area. You get the execution thing in technology like Spark and Dagster and Airflow and all this kind of stuff. You don't really get the object graph. The dog basically is a way of an object graph. That's really what it is. And it's very, very good at describing business process. So coming back to our whole thing. So I've been using it as object graphs, object-oriented program for 30, 40 years. I thought, can we actually apply this to the world that I live in? So fundamentally, can I actually describe a business process using an object graph? So if I have a customer onboarding process, for instance, we get the initial customer touch point. Customer logs in. That's an object. Then we go to give me the customer details. That's an object. We can maybe do some AML or some checking, some compliance. That's another object. That's another object. And each of those states along that business process actually has some data captured, but it also has a method that's executed. So it's very, very good for doing business process modeling, that type of stuff, but it's also very good at doing data as well. So each of those nodes could be just some simple logic, or it could call out to a web service, or it could call out to a big data platform, or it could call out to an AI model, or it could call out to anything. So actually you can start describing your business process in technical terms. And that's really what the dog is. It's an object graph which has data nodes and execution nodes. So when I basically do, say, like the onboarding process, or I'm doing something like a credit risk, give me a credit score. And that's one of my classic ones. And I've built this a number of times for different clients. I want to take in data from whatever I'm doing. So say I'm trying to score a loan, I take data in from the loan. So I'm doing classic kind of data processing. But then I want to actually then build some features. Again, another data process transformation. And then once you want to score it, I want to call out to a credit model, which is a machine learning model. We've got one like a random forest. That's an object which actually calls out to a machine learning model that returns back a data. And then I want to do a report. So I call out something like Anthropic or a local LLM to actually generate the report. You've got like 4 or 5 steps. And it's all described as this kind of object graph, which each step has its own data, but has methods on it as well. fundamentally. So that's really the kind of the genesis of the dog process.
Which is fair. See, now challenge comes or fear comes that if we go one step back, right, we are designing, let's say, a basic data product, right? When we create data product, what comes in our mind? Anybody's mind is, hey, you have to pull from source, you have to
Yeah,
land it somewhere, then
yeah.
you have to do data modeling, then you have to create a semantic layer, and then you have to create a Power BI report or any kind of output. That normally comes into a mind, right? Now,
That's the traditional way of doing it, right? That's the way that the go-to process that everyone goes to. Yeah, in data,
everyone,
not in transactional side of the fence or the software side of the fence, but definitely in the data side of the fence. Definitely.
data side, right? So now the question, because there are multiple layers there, which is yes,
Yeah,
the waterfall thing. But when
yeah.
we go towards agile, even data vault or focal or anchor do give us this capability where we can go agile. We don't have to go for waterfall, right? Even you need to add a column. We can do it in a day, but we can't do it in 3NF or dimensional modeling. But in data vault, we can do it, right? So agile methodology do come there, but that
Can I just challenge that for a second? Can I just challenge that because it's quite that exactly right. So the traditional process is you ingest data, you land it, you do some sort of modeling, you do some semantic layer, then you build the report. Just did a post about this yesterday. How long does that take for new data?
new data or new element.
Well, right. So if it's a new,
Element.
so
So data vault guru says that if
so
a
if it's a new element, it's new data coming in, right?
yeah new data comes in, they can do it in a one day. That's what.
If it conforms to the model and if it conforms to the semantic model. If it doesn't, so say I want to say that my classic use case is one of my customers is a 100-year-old company. It does basically has a 4.5 million customer base. It's has customers who have been there for like 50, 60 years. Yeah, the senior citizens. When they were on board, they didn't have date of birth associated with them fundamentally, because back 50 years ago, you didn't need date of birth. There's about 100,000 of those. Let's say 10% of them don't have that. Marketing want to do a new campaign to actually start modeling, do segmentation around that.
Hmm.
They have similar systems you've actually set up. It's a bit more complicated. Actually, we'll talk about this in a minute. When the layers you talk about actually never are that few layers. There's normally 3 or 4 different layers in there, and they have 6 layers in their platform, right? So we'll go and actually onboard date of birth. Well, first of all, marketing team got to go and source that from somewhere, right? And that's a whole business problem, right? They have to go out to hundreds, have to identify these people and then go to the campaign, that kind of stuff. Then they have to bring in date of birth. And that's like, well, we need date of birth, but actually, we haven't done segmentation before. So actually, how do we actually model that all the way through the system? Every step becomes a challenge fundamentally. And actually to do that one element took them 6 to 9 months fundamentally to go through all the layers. So actually, I think, and this is the challenge, right? This is the actual challenge. And in the AI, until we get the AI agentic world, we're doing stuff minute by minute, hour by hour, not even day by day
Yeah.
sometimes.
Let's pause this here because this is very core. That is where I think
That's it.
AI can really play a part. So let me bring that data world input over here, right? So
Yeah.
when we say it takes 3 to 9 months or 3 to 6 months, it was because we were building data warehouses in a centralized or enterprise environment where we used to have a subject area. When we say subject area, let's take finance, right? Finance or maybe sales, right? What happens in every subject area? There are always three kind of tables. There are transaction tables, there are master table, and there are reference tables. Transaction tables are always dedicated to the subject area, right?
Yeah.
Yeah, finance transaction table will be finance, sales transaction table
Yeah.
will be sales, right? But when it
Yeah.
comes to master and reference table, that is where real data modeling come into picture. That is where every subject area comes and start using the same thing. And that is where a lot of time was consumed, right? That is why everybody wanted
Traditionally,
to,
yes. Yeah. Agree.
yeah, right? Now this agile methodology came in, which is data vault. Data vault is very old, but it just became famous, I think, because of data mesh and XYZ. Actually, data mesh is also very old, but I think it got famous in last less than a decade back. And that is where, if you go into data vault, right, what it says again, it said that I will look into a different angle because what people say that you pull the new data element and directly throw into a data vault, and when it goes into it's very fast. It's very fast because every new column is attached or tagged with the business key. So whatever you bring, so in these models, you bring the business keys up front, and any new columns come which is non-business key, which attach to that up to the granular level, right? That is where things move very fast. Now I will come towards how graph work. I really want to understand that because
Yeah.
I have a pipeline. The only delay I can see is I need to ask my developer, hey, pull from system, put into a landing, put into a data preparation layer, which is data vault or focal or anchor, and then load. Okay, you cannot hit a direct read query on vault models because there are so many joins. You have to transform into a semantic layer as well. That I agree with you. In that semantic layer depends on the business requirement. Now, my business requirement in the same department is one, and your is different. So, semantic layer is different for me and different for you. Now, when new element comes, that is where challenges come, which still coming. I'm agreeing on that. Now, tell me when you bring this graph, how this dog works. Like when you pull from source to landing, you have a different node, execution node, because layers will still be there, I'm sure, but you will work into a different, how actually you work, because this layer will
Yeah.
still remain there, right? Because
No.
column, no, is it?
No, layer does not relate. Well, not in the same sort of way. No, no. So the interesting thing is in the again in the AI world and the machine learning world, for instance, you don't know what data you want when you start modeling a process. Fundamentally, you don't. You don't know what you're trying to uncover a pattern.
Yeah.
So when you say again, my credit risk one is a classic example, right? So if I want to do a score alone. Now I've got loan transactions, so the loan application transactions, but I've also got transactions from history from previous. They may have a credit card, they may have other things around it. I may have some social media I want to use. I may want there's a whole range of different data sets I want, but I don't know which ones I need when I start with. And this is
Fair
what
enough.
this is the key problem, right, with the process you talked about. In order to have that iteration to go and find, I might end up using these three columns. Well, might get one from finance, I might get one from the department in sales, I might get one from marketing, I might get one from the internet, I might go on from the supply. I don't know that. You can't. The process you just talked about doesn't work for machine learning. Right? Or it does. It just takes 6 months because every time you want to progress a new data item, you have to go through that whole process
No, but
before you can actually use it.
still
So,
there is.
okay, so this is the first problem. The second problem is, I don't want a whole semantic layer. I want three columns, right? Fundamentally. So why can't I go into the existing system, the direct systems, in a controlled manner, which is super important, grab the data I want, and obviously if there's source systems actually have complex data models that I'll need data engineering and who understand it, and I totally get that, all that. But if I can't, why can't I sit with the system owners or the system developers there, say which one's this and what's that, do with it, maybe the business hunting, and extract those out, and then I go back and do my EDA and what have you, try them all that, and then I didn't have to go back. Yeah, no, I want this column, I want that column, I want that column. So you have this process, and this is also how I don't care about data models as an AI person, I don't get data models actually, especially intermediate ones, is a lossy business. So if I do a transformation into some sort of intermediate semantic layer, that's based on assumptions of the architect at the time. They may lose information because they haven't forecasted what the use case they want to use. As an AI person, I don't care about that. I want to go and see what the actual joins are in the source system. And a lot of data scientists hate that. So just prepare me some data and give it to me. I shouldn't do the modeling. But for me, understanding the models inside the source system is as important for the data scientists as it is for everyone else. So they understand the business process, understand patterns, understand why that is. Obviously, they'll need help, and then get that iteration through. And this is really the key. So what we're trying to do is from just a pure data sourcing perspective, we want you to shrink that stack right down so we get that agile, and then we want to join together with the docs. So, for instance, that credit risk, that credit scoring pipeline, there are 3 or 4 different hops to it. I can use them to join those together. Each one of those hops potentially has its own like micro pipeline. This is kind of the microservices data mesh type approach. So I get data from the source system as its own little pipeline, so surface those out. I create some features, another little pipeline based on that. I create a model that has a potentially another little pipeline because doing some of the bits and pieces, and then I have another, and then the output of that goes to another microservice that does the report generation. There might be a decision model that goes to a credit officer around that as
Also,
well. So
so you have all those steps. See, that is where I'm coming. You have all those
yeah,
steps. But I think you're doing on a mini basis, micro basis. If you need three column with a primary key, you will only process that. And you will,
Yeah,
of course, you need to know the end use case. What is the use case? Hey, I'm a credit score, as you mentioned. I want to see a
yeah.
credit score for certain products, for certain region, for certain
Or it might be
environment.
individual. This is individual. This is actually scoring an individual. So the
Yeah, yeah,
business key is really the customer ID, right? Fundamentally.
absolutely. So you are going at a very micro level, right? But all those layers are still there. Now my key question comes. No, so layers are there, right? Because you need to pull from source. You need to write, as you mentioned, reference tables. You have to create reference table. Then you have to create something which can be
For that
seen.
use case, I don't need a reference table. For that use case, I don't need a reference table at all.
But where
I
then?
just need, just need a customer ID.
Okay, I have so many questions, John.
Yeah.
Bear with me. I just like you, I am also into data. So now the whole
Go
architecture
for it.
is
Yeah.
on mind. So for
Yeah.
me, first it was waterfall, which was 3NF and star schema, and
Yeah.
yeah, and this dimension modeling. Second piece was data
For
world.
reporting, for reporting, for other use cases and data, it wasn't right.
No. What I mean is when we talk about data world, right? When what comes in your mind is when you need to write down the whole pipeline. First approach is waterfall, which is 3NF and dimensional modeling. Second approach comes, which is to process all this, is agile, which is uh, vault, focal, and anchor. And third one comes where Papini Bridge and Hook comes. So there are three kind of areas. Now fourth is yours, and I'm very much interested to really understand this. Right. So
Yeah.
I will go a little bit deeper. Don't mind.
Go on.
Now,
Go on.
when your object, okay, let me throw this question I was about to throw later. Does your dog only work if you have a very good metadata? Because what I feel is, oh, you're also not dependent on
Doesn't
metadata.
matter. Oh, so when you say metadata, what do you mean? What do you mean? Just
Metadata. Because when your agentic AI dogs run, it need to go and find from somewhere.
yeah,
Or your agent knows somewhere is where, until unless you don't have a technical data of the whole source system. You need to know table name, what table name means, columns, what
yeah,
column means, how many primary key, foreign keys are there. All those you need to know. Otherwise, today I say, hey, go and get the date of birth. Over there, date of birth will be written DOB somewhere. Somewhere it will be written something. How your agent. So I'm going right at the
yeah.
source. Do you need that metadata?
Not necessarily. So what I've been doing the last few months really interesting is actually pointing, and it's not just the agent, it's the model basically. So there's differentiate between agentic and AI models, right? There's agentic is a particular type of model, or type of component that uses models to actually make decisions, right? And there's a whole architecture around that, about shared memory space, goals, and all that stuff. But if we talk about take a step back to models, so if I point a model at a data set, for instance, I can get that data models today, or AI models today, especially open source ones, are actually very good at determining what that data is.
Oh, they
So,
go and find out kind of data itself as well.
so they can actually look at the data and go, oh, I think this is a bunch of sales transactions. I can actually see. So what they can do is they can get you like 40, 50, 60% of the way there, fundamentally. You know? And again, if you remember, if I'm doing an AI model, like a credit scoring model, I'm only interested in the patterns that influence the outcome of the loan. I'm not interested in all the foreign keys and that kind of stuff, unless those what an AI model wants is a big white flat table of columns, right, features, and the one hot coding and all that kind of stuff. That's what they're interested in. So what features are high correlative to the actual outcome I'm getting from them. So, it might be late payments, it might be other products, it might be age, it's those types of things. So actually the AI model doesn't care about it, and it doesn't know about foreign keys, doesn't know about data models, it doesn't care about them. So what's the fastest way we can get to those sort of things? So if you have a complex data model, um, yeah, you will sometimes need SMEs to actually go in there and actually this is, like SAP, for instance, we've done something on SAP, and that's a nightmare because it's a massively complicated data model, so you need SMEs to do that. But what we have been found is actually using, open source models and also kind of Anthropic and these other large models. So I say, here's the data set. What's this actually telling me? What type of data is it? And it actually understands enough to be able to give me that acceleration to be able to do that. So it's not 100%, but it certainly gets a long way there.
No, agree. So you are bringing open source kind of libraries which can tell you what data they're reading, what it is. So actually,
Yeah, yeah, yeah. So the agentic thing the dog is one piece of the puzzle. What we do is bring it all together using AI almost at every single point to actually help accelerate all the work, manual work.
absolutely. I want to stay on this amount or maybe a date of birth, right? Because if you talk about date of birth, if there is a content in a column which is a date, you will never know whether it's a date or it's a transactional date or it's a death date of someone or it's some expiry date. So you will need a context to know whether this date is what. It will always be, I think, it will be there. Just
Totally
like
agree. No, well, not necessarily. Like I said, sometimes actually, if I give it like a table of sales
Mhm,
transactions, and it's got like three dates in it, and
mhm.
it's got some, and the column name is a little bit spurious. You kind of look and go, I think that's a lot of the models actually take a good guessing. Oh, I think this is the execution. This is the order date. I think this is this is the. It actually makes quite a good guess at it. Now, like it's never 100% because it hallucinates and there's all sorts of things. But what it can do, a bit like MDM, right, where you basically throw something at an MDM solution and go, oh, I think this. I've got high confidence that this, and this, and I've got low confidence that this. You can implement that with AI, not just expensive, fancy Gen models. You can use simple machine learning models. I mean, I've done stuff with naive based reconcile transactions together and actually do probabilistic matching between fuzzy matching, this type of stuff. So you can actually there's kind of a staircase of models that you can actually apply. And again, good MDM solutions do this. Jason Taylor has one doing NC resolution. We've done a few of those. You can actually apply a lot of those to actually give you that acceleration, give you the 50, 60, 70% of that fundamentally. So you don't have to spend 6 months trying to model the world and trying to do all this foundation stuff again. And that's really the key. When you've got the matches which are low accuracy or low confidence, you go right to the SME. What does this actually mean? But it gives you that massive acceleration to start with.
Oh, so okay. Now I'm getting your point. What you're saying is the draft version comes out very fast. Now, when the
Yeah.
draft version comes out, rather than you go and ask someone and start creating a perfect solution, you start with the first version. And to meet to the business is always if the score is low. Whatever low score is, you go and check them. Hey, I can see I was trying to find out date of birth, but it seems it's not a date of birth. Can you redirect me to the right column? And you simply go and ask your agent to pick
Yeah.
up that. Okay.
Or you ask the individual in there. So again, there'll be some data models which are really simple, which can be almost automated. Almost there's some which are really complicated, and it's having that continuum. So for me, agentic AI is a suite of capability, and it's being able to apply AI to not just do the decision making. Because everyone gets caught up on I point this agent and it books me a ticket. It's like that's kind of the simple use case. In
Yeah.
big enterprise, messy IT estates and data estates, that doesn't work. There's a load of foundation work, but you need to be able to accelerate that foundation, inject humans into the loop at the right place to be able to accelerate it. But we've got to get away from this kind of we have to handcraft everything and we have to spend 6 months, 9 months building this wonderful enterprise data model, star schema, this kind of stuff. You just don't need to do that because I've been doing this for 6 to 9 months and I can create into business processes on complex schemas really, really in days, really, really quickly. Because that's ultimately the business aren't paying you the model data. The model is paying for you to actually get output quickly. And also with AI, what you want to be able to do is actually, test if it works really quickly. You can't spend 6 to 9 months doing that, which I've seen happen as well.
Absolutely. So you are saying your product is a pre-built product, or you start for every customer a new thing?
We start a new thing. So basically, what we do is there's three bits to the product we've got. So basically, there's a whole value bit which we'll talk about, I think, another day, because we spent whole session on that, where I'm asking what the outcome is, and then you basically ask value-based questions, and it actually generates a sample business process based on those value-based questions. So you get the initial candidate of the end-to-end data object graph of that business process based on what you want to do. So there's that piece. Then you basically go in, you've got the candidate business process, you can show to the business and go, actually, this is your business process, this is what you want to do, this kind of stuff, and talk around it. The next piece is basically, I want to connect this data object graph up to real things. So I actually want to start, and each one of those hops in the data, each one of those vertices in the data object graph is a data product. And the relationship is basically calling it through, each one calling the other one through the graph. And then I want to go and connect those data products up. So then you have AI, which can go into each of those data products. Here's a data set. We want 3 data sets, one from sales, one from CRM, one from, I don't know, the internet. We connect them up and go, right, find the right data. You think the right data is for this. Here's our suite of systems. You go and find the right data. You go, I think it is, because I know what you're trying to do, because I've got context of the whole business process, which is really key in it. And in data world, you don't often have that. You get an order in from your use case developer or whatever and say, I need the data. So what do you need it for? And you end up going backwards and forwards. Because we've got the whole end-to-end business process defined in good enough form and the context around it, we've got all the questions from the business, we can feed all that into the AI and say that this is what we're trying to achieve. Here's the source systems, here's the data sets, go and find those and come up with your best guess on what that looks like. And sometimes it does a really good job, sometimes it doesn't do a great job, but actually it always gives us an acceleration around that.
So don't tell me that Shane Gibson is coming and we're going to work with you.
I only found out that today, actually, funny enough, or
Because
this morning. So yeah.
I feel that information product canvas which he has come up with, that can be a super good input for your solution. Because
Yeah, so obviously we have data product pyramid process, which is all built around, which has knowledge products, it has information products, and it has decision products, and it has data services. So we've built this into the tool. So actually, you get a full pyramid of of products, and we have a data product canvas, very much like Shane's information product, but it's built into the tool fundamentally. So you can actually then say, give me all the products that I need for this end-to-end business process, but based on the value. So I say, we've got whole value metrics around that also, and we can track all that thing. So we have something very similar to what Shane's done. What Shane's built is brilliant, but we've got that, but we actually go quite beyond it, because it's not just the information, it's the decision, i.e. the outcome, that's tied to a business value. And we have it generates the actual business process, which we then go and implement. So we have this kind of end-to-end flow from value all the way down to implementation and operation in there as well.
So how about Nicholas' tool, which is UE tool? Have you looked
Yes.
at that tool?
Yeah, so I know Nicholas very well. He's actually a good friend of mine. Yeah, so his tool is brilliant. He goes way beyond that. So his whole kind of value of portfolio, he's about valuing and basically managing entire portfolio, which is really good. Yeah.
My apologies, because when your dogs and your product is creating a lot of data products and decommissioning it and then creating it, then decommissioning, someone need to have a track of it, right? You have YouTube and you decom, right? So I think UE has to be there. This kind of tool has to be there, which can keep the history. Hey, you have this idea, and when you receive something, every day some products are coming and going. Okay, so you are saying you will also connect with that. Okay,
Absolutely. Yeah.
so being a data guy, I'm still a little bit lost. Where you will host your data? Big question.
Yeah. So it's interesting you talked about semantic models. So we have in the product a virtualization layer, data fabric layer, if you like. So what we try and do, and when you define your data products on the graph, so each one says, again, come back to the credit model one. So we've got an ingestion one from 3 different systems, from sales, marketing, CRM, and an external one, say Facebook or whatever. Each one of those products has its own little stack in it. So we deploy those as what are called data product containers, which are effectively little microservices, and each one has an embedded SQL engine or data virtualization engine in it. So when I query, so if I hit the API and say, give me all the data for the CRM system for this data set that you've exposed, so I've got the customer records, it will then can either go and query the CRM system directly through the data virtualization system, so we try and keep data. Obviously, if we're not allowed to do that, or if there's performance issues or security, we can do things like CDC, and the data gets change data capture, where the data gets automatically published into the product itself, and that's held in memory. Fundamentally, so it's an ephemeral, but it's synchronized. Yeah, exactly right. Or we can things like connect to a resilient copy, or if they've got backup or that kind of stuff, if that sort of stuff. But it's held actually either in memory in the product itself, and other things can then query it, or it can actually push down into the actual source transaction. Our ideal is to push in the transactional system, ideally, because that's the source of truth. But even if we store it, it's always synchronized to the transactional system, because we don't want to copy data from a copy and break that synchronization, because that's where all the problems come in. And again, we come back to the original, talked about layers and data folders. That gets broken, right? And that's actually quite tricky to do, because you're transforming data, and we're not transforming data. So the model itself, or the use case, sees the source data and the source data model directly, fundamentally.
Yeah, see, that is where my next question is coming, because in data world, we also do care about read historical data. And
Yeah.
as you mentioned, CDC data, it's not getting CDC data is not very easy, right? You can, yeah, transactional data, yes, you can always bring in,
Yeah.
latest data that is also
Yeah.
kind of a CDC. But once you go into a bigger master data, you have to dig out the,
Yeah.
golden record, and you have to refer here and there.
Mhm.
And then when you expose to the business, because one of your agents will be creating up maybe a Power BI or Tableau dashboard, right? And that
Yeah.
dashboard need to read from somewhere.
Yeah.
Where my mindset, after all discussing this thing, I think correct me if I'm wrong, your product will be more over a real time product where small data sets are required, not historical, right?
So the data product itself can do both. So for instance, so inside the data product, it's a microservice, and we have a bunch of logic in there. So basically, we can spin up it has a virtual schema,
Hmm.
and you could have a table in there which is a CDC table coming in. You could have another table in there which is historical, so it could actually store the historical data, and I could put it in memory, and it could actually federate out to this, or it could put it into another database or what have you. So you could actually say, when I query the data product through the API, I say, give me the data for this table, this is the real time one. Give me the data for the historical table. You can actually store both of this within the confines of the microservice. And I say the microservice could be because it's got a SQL engine built into it, and you can use DuckDB or whatever it is. You can actually have a historical table built in there. We've got a columnar format which does that very nicely, and I also can back off things like blob stories and that kind of stuff. So the product itself can have a real-time table and a historical table, and obviously a bit like the old Lambda architecture, right? But that's all contained within the actual the data product itself.
See, that is where I think you are going into the right direction and in a good direction. Where I'm coming is, I think your product is not getting rid of layers. I think your product is moreover getting rid of how to implement things and how to
It's
run
compressing
things.
the layers. It's
Yes.
compressing the layers, and that's the point. The layers are still there to a degree, but it's compressing them down. You're not hitting on 4, 5, 6 layers. Yeah, exactly.
Fair enough. But see, when I talk about layers, I normally talk about, okay, let's go into that. We have enough time and the discussion is going good. Right? Layers has meaning. A lot of people create useless layers, but I
Yeah,
don't. For example,
indeed.
landing in raw layer, there is a need for that, and I can defend that. For example, source system is SAP source system. SAP normally don't allow you more than one or two connectors.
Yeah,
You have hundreds of products in agentic AI, they will never allow you. Even they allow you, each
yeah,
connector will charge you millions or millions of dollars. So
yeah,
you will end up bringing data into a raw. That's one use case. Second use case is, if you directly throw from source into a RDBM or some kind of databases, then you have to maintain the versioning as well. Because the moment
yeah,
SAP goes up and your RDBMS or any kind of database version is less, is compatibility all lost. That's why normally
yeah,
what in data what we do is bring everything into a flat file format. So disconnect from the source. There are
yeah,
many other reasons as well. So there is a
yeah,
reason for, so raw. Yes, 90% real time use cases might not need raw because you could directly go into semantic, but you will end up having it. But I think
yeah,
your product can really help us, rather than a developer is creating, takes 2 weeks to develop a pipeline. Here, your product can, as it is
yeah,
already connected, you simply say, I need a data part. It will go and find out based on the metadata
yeah,
library and pull it. Now from there, when it
exactly.
goes to staging layer, see, do remember that I'm also keeping historical data as well. Because the
Mhm.
moment bigger decision come from a historical.
Yeah,
If you go into memory, you can't keep terabytes of data into memory. If you have to throw into object storage or some kind of down there, So you can
Yeah.
refer, right? Now
Yeah.
come the staging layer. Staging layer, normally what happens, okay, dates are coming into multiple formats, special characters are coming, master data is not digging. So everything you do into staging. So if there are 10 kind of data types are coming and you take it from raw directly into your semantic, your memory will be very highly used because in target you want the one date format. I'm just giving you an example.
Yeah.
Like
Yeah.
this,
Mhm.
so staging is there. Now data preparation comes. Yes, we can get rid of data preparation. We can go directly to semantic. Fair. But the question comes if you go directly to the semantic layer of a business representative data model, you will never have golden record. You will never have single source of truth. We can live with it. I personally feel yes, you can bypass it, but historically, you data still at back end still go into data preparation. That's my thought process actually. So
Okay.
now my question comes to you. Now
Go
my
on.
question,
Go
sorry,
on.
yeah. My question comes to because these are the realities, ground realities. As I always say, there is a solution architecture. Then there is what was the second one? Solution architecture,
Yeah.
implementation
Well,
strategy, and
yeah.
ground reality. Ground reality is very important because if you don't have historical data, your
Yeah.
your auditors come and ask you are dead. So how you are looking into this? Are you getting rid of that foundation or
No.
you're still keeping it?
So we're compressing it. So the interesting thing is we have absolutely have raw, always have raw, right? But raw is sometimes virtual, not physical, fundamentally, depending on the size of the data, right? Depending if you can query the whole thing. Now we do have historical data, so in the data product, I said you can have the current table, current version, and the historical
Okay.
version. Fundamentally, you can have it absolutely at the raw level, fundamentally. But all the stuff you just talked about, the data preparation, the conforming and staging the data stuff, we do that on the use case level
Fair
fundamentally.
enough.
So we're not building it. So we can all those data preparation semantic, all compression. The next level is basically the consumption layer inside the product for that particular use case. So all those things you just talked about get done from the raw into that layer. So if we need dates corrected, we need data quality rules, we need all that kind of stuff. But it's all done for the specific use case. So it's much smaller. So what we end up doing is actually a much smaller set of rules and configuration and semantic modeling because it's basic for the use case. Now the other thing, and that is on the raw real-time table, but also on the historical table. Because the historical table, I mean, we could just have a trigger on the raw after it's done that. We have the historical on that, and it gets pushed out to a database or to blob store or what have you. So, and you can query them across the schema. So we absolutely, yeah, and the point is we're completely compressing that whole thing down fundamentally. And then getting the agility and getting the whole thing as well. So, and the only thing what we do is actually also when I was talking about microservices, we actually break the microservices paradigm, and I'm going to put my hand up there. We publish those data sets into a catalog. So another data product. So say someone does a merge. Since you talk about source of truth, say I'm doing a pipeline for customer records, and there are three customer systems fundamentally. And we do a merge of those customers, basically an entity resolution, MDM type process inside the product as well. The source of truth is always those systems because we're synchronized. So we always have source of truth because we actually go directly to the source systems, and they're really the source of truth, not some intermediate model. We synchronize those together. Someone does all the work merging those together, doesn't actually do the entity resolution model, doing fuzzy match, whatever. The data product then surfaces a combined set of customers. We publish the intermediate ones and everything into the catalog. So another product can interject into that, say, I want the actual customer records from that particular source system, but I can query that data product directly, and it goes outside sort of the microservices. Apparently, we can query that directly through that sort of virtualized semantic layer, the virtualized solution. So people can always access them, and they access them through the product. And that solves your SAP problem, where if that's a CRM in SAP or whatever, or a bunch of orders, it's not going directly to SAP unless that product is querying it directly. But if it's not, if it's materializing those in a real time and also in a historical sense, other products can query that data sets inside that virtual schema, inside the product, not through the API, but through the virtualization solution. So fundamentally, we kind of come in at the side of the microservice. And I know microservice purists will throw their hands up in horror, but in the data world, you have to do it because the whole challenge of doing data only microservices is the join. I've fallen foul of this many times. You want to be able to join using database technology, like SQL technology, not API technology, because that's where GraphQL kind of
Yeah.
falls down that. Does that make
Yeah.
sense?
Yeah, it makes sense. I think the discussion is going very, very good and technical as well, and I'm loving it, right? Because where I see your product is to squeezing down the whole process of delivering a use case,
Exactly,
right?
exactly right.
Delivering a use case, not maintaining. I would like to humbly put this thing over here that
Cool.
maintaining comes in. See, delivery is one thing, maintaining is BAU. And I think
Yeah.
you don't care how someone maintain it. You care when customer comes to you and they say, hey, I need something. You say, okay, I'll give you in a couple of days. I think that's what your target audience is. Correct me if I'm wrong.
So there's two sides to it. You're absolutely right. So I think the thing we do that first bit brilliantly, as you said. That's something I put together a proof of concept, proof of value, which is even more important in a few days. We've done this a number of times. Sometimes there's no value, so we don't, it doesn't continue. Sometimes there is value, and we do continue. And that, but we get to that in like days rather than months, which is absolutely important. The interesting thing is the next piece is how do you operationalize it? How do you productionize it? How do you publish and deliver it into the thing? Now, we can do a number of different things. We can publish a microservice. If you've got a Kubernetes stack or something like that, or a distributed cluster for doing Docker containers, we can go right bang on that, and now you've got all your operations, all your management, that kind of stuff. That's kind of the kind of the fast route. We've got a more traditional route where companies want to actually go and build those things. So we say, here's the business process, here's all the containers, here's all the specifications for those, here's what we learned, here's all the data and that kind of stuff, and then we create a big spec and that kind of stuff, and the developers can come and introspect, and then go and build it on their stack and on their, So if we had like a high regulatory one, they spend a lot of money getting a regulatory kind of processes. They've got the definitions. They can then go away and build them, onboard them, and actually build them in the way they want to do it. So there's really two kind of modes. But yeah, the bit that we're kind of focusing on at the moment is that front end. Let's prove it out. Let's show what it is. Let's show the feasibility. Let's show the value of it, and then give something that the tech teams can go away and actually technically build because it's all laid out for. It's rather than drawing whiteboard diagrams and all that kind of stuff. So yeah, definitely.
Yes, because see, you remember that last time every department had their own data and IT
Yeah,
teams, and there
yeah,
used to be a small team sitting somewhere who were doing quick deliveries for everyone.
yeah,
So I
yeah,
think your product is that small quick delivery team who don't care about how semantics work, how multiple layers work, don't
yeah.
care. We come and we deliver, and then we will think whichever becomes successful, then think about it whether you really want to go waterfall, you want to go data vault, who cares? Because your dog is there and backend it can be anything, right? I think you don't mind. If I
Well,
have
so yeah.
critical question. If
Well,
I already have a data vault implemented at my place, I have an investment there. I bring you, will you get rid of that? Or you say, let it be there, I will reuse it.
if we can reuse it, we reuse it. I mean, we don't advocate getting rid of anything because it's cost and time and effort, and a lot of the times when these sort of central warehousing type models, Data Vault, Snowflake, and this
That's
kind
the
of thing.
ground reality, right? Investment is there. You
Well,
are
I
paying
mean,
on it. Yeah.
the ground reality is in these sort of systems. I would argue. This is an interpretation for analytical use cases, and that's what the company's invested a lot of time, money, and energy. And sometimes a lot of that institutional knowledge is lost, and you can't touch them because it's like I don't know. This was built 5 years ago, right? So if the data is in there and we want to use it, let's reuse that. That's basically what I would say. But the interesting thing, we haven't really talked about AI agentic at all yet. Funny enough, if you look at I totally agree with you. In traditional organisations where this is the case, we see this again and again and again and again. We've got an existing process, we've got our existing systems, this kind of stuff, and we want to be able to use them. What's really changing the game a little bit is the agentic model. Because the agentic model basically says, I can't work like that. Fundamentally, it doesn't work like that. If you look at the way agents fundamentally are functions at work, they go and basically make decisions. They basically build their execution processes ephemerally, dynamically. They need agility. They need this kind of, and they're business process driven. So actually, you start an agent into that kind of world, you're going to get a lot from the agent. So it's going to, it's going to be basically a workflow, right? Because it's not an agent. It's not an agent really at all. It's basically say we've got this set data, so we've got this kind of what is required. I'm going to actually implement my process this way because that's the way that all the technology is set up for. If you take, if you look at an AI native organization, we start to see a few of those come through, and it's quite interesting. They're not built like that at all. But basically, it's You need the agent to make the decision what it needs to do. You need that agility. And this is kind of, I've been sort of posting this for the last couple of days. This is the environment that an agent really needs to work in. If you try and put it into the old system, the old way, it's gonna not break, but it's going to be very slow. It's going to be frictionless, and it's not going to add a lot of value fundamentally.
Yeah, but John, then this challenge come, right? Because we all know that just because of, you know, fall down of generative AI, which left a very bad impact on the industry, right? Because
Yeah, no, Chris.
it came big and never produced anything good. Now suddenly agentic AI come.
Well, I'm not sure now. So let's just clear. I worked as a CTO of a Gen AI company 3 years ago, and they went to production. They were making money and that kind. I mean, they ended up getting screwed by OpenAI. But that's the whole story. The business model was there, it was working, and it was in production. And we had customers and stuff. So let's be clear. There are Gen AI projects or solutions that do work. I mean, lovable. It's just hit to a 200 million ARR or something ridiculous, the cursor. These are Gen AI. I mean, they're kind of technical ones, but they are. So there are, and so the industry is actually now starting to move. And I think, in large traditional enterprises, you're absolutely right. And we've been bitten by this quite a few times. And it's not just Gen AI. This is an innovation problem. I talk a lot about this. We've got this innovative solution that can really improve the business, can reduce money, can reduce costs, make revenues, kind of stuff. It doesn't work and it fails. Not necessarily because the technology works, sometimes it is the technology, sometimes it's the models, but it fails because your business change hasn't been thought about. And again, I did a post about this morning on LinkedIn. This is the biggest problem around it. People don't understand how AI really works. It's experimental, it's improving accuracy. It's not like I give you 10 million, I get a guarantee this outcome, although I argue most IT projects aren't like that anyway, even though we're still going that fallacy. It's about experiments, it's about making small bets, it's about nudging, it's about going off and getting data, it's about this continuous experimentation and iteration, a true product lifecycle, actually. And most organizations aren't set up for that. And that's really the thing that Gen AI, where a lot of failures are happening.
No, I absolutely agree with you. When I say that it did not deliver as per promise means our salespeople overpromised. That's what I meant. Because generative AI
Yeah.
cannot do everything. Now,
No,
when
indeed. So there's a lot of that, definitely a lot of that. Yes, yes,
yeah, you
absolutely.
have to get Gen AI work on the use cases which it can do, which I
Exactly right.
personally
Yes.
is
Yeah,
on
yeah, yeah.
structured data, not on structured data. I would love to hear use cases where there are big, huge, successful
Yeah.
structured data, Gen AI solution successful. I would love to hear that, but I haven't heard about it. But I think
So again, yeah, yeah. I mean, also the other thing is Gen AI is getting all the hype, right? There's AI has been around for ages. You see that there are massive, great use cases in the health industry using AI, right? Neural networks, substrate around that kind of stuff. And that's the other thing I'd say. This one model to rule them all. People are buying into the execs are buying into the hype from OpenAI and Anthropic. I just see the UK government just signed 2 deals with these companies that make my heart sink. What I found is generative AI is very good at this. It's a summarization engine. That's what it does. It creates derivative work based on tokens. You put it as a component for the right piece of it, because lots of people are trying to use Gen AI for everything because that's what they believe the hype. And this is why I talked about the credit process. I'll come back to that again. We use Gen AI to generate a report. Now it changes sometimes. We don't use to generate a credit score. We use good old random forest, tried and tested machine learning models to do that because they're much more accurate and much more trusted in this kind of stuff. So again, it's not just one size fits all. And that I think we see a lot of this in the world. We throw things into Copilot and expect it all to be wonderful, and it doesn't work that way because you understand how Gen AI actually works and which bit of the puzzle. But that's an innovation problem, right? I've had this not just in Gen AI. I've had this many years ago. Come up with a new innovative way of doing some new analytics, and it's done. The business change hasn't happened because people don't want to adopt it. Because I've still been doing my process for 20 years. Why do I need to do that? So I think there are some multiple factors involved.
absolutely. See, that's where I was coming that wherever
Yeah,
people have seen a success use case, they would love
yeah,
it. But
yeah,
90% who haven't, they're also scared of getting into agentic AI because agentic AI is a
yeah,
whole ecosystem. For
yeah.
in agentic AI, traditional AI and generative AI is just one agent doing some certain
Or
work,
one
right?
component. Yes, yeah, yeah.
It's
It's one
just one
component of it. Yeah,
component, right?
yeah,
So
totally. Yeah,
yeah, where I was coming from my angle was that if people are so afraid of generative AI, how come? What trend you are seeing that people are comfortable with agentic AI? Because people who are agentic AI, not generative AI, agentic AI. Because
yeah,
agentic AI,
yeah,
as you mentioned, will do their own decisions, X, Y, Z. Won't, who will allow agents to go into source system? I call it sniffing, right? Sniff into the source
Yes.
system because it's not a complete thing, right? Sniff into
Yeah,
every
yeah,
source
yeah, yeah.
system and go and find a relevant data. Then this PII privacy issues, GDPR issues, all these issues, how do you see that? Aren't those challenges?
So yeah, that's a really good point. I mean, it is a challenge, but you can build that into the agent. You can build that into the sniffing process, right? Does this look like PII? Does this look like if you think it's PII, you think it's GDPR kind of data, flag it up, right? And that's building into the system. What people are doing is basically using LangChain and these other open source, connecting them to MCP, putting them, and not thinking about it. Again, just because you do agentic doesn't mean you stop doing software engineering, right? And there's a lot of talking about this. It's this kind of, again, this is the hype thing. Wow, I can just connect things up and do happy path and blah 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 blah. No, you still have to build a software engineering solution that's robust, compliant, all the others. These are just normal requirements in there fundamentally. So I think that's where but you want to remember on the kind of Gen AI, we're on this, and the agentic, we're on the sort of wave, the crest of the wave at the moment. Let's all calm down. You'll get a few big lawsuits, you'll get a few big kind of, a few big kind of high profile people step back, and then it'll bounce out. So you get this kind of hysteresis, you go up and then you go down and it sort of levels out. We're still in the up and down business. But again, just because you do agentic stuff does not mean you stop doing software engineering and all the good discipline around that. And that's something that's, I think, it's being lost at the moment.
Okay, okay, let me say it out in 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 a online session is I'm not a big fan of software engineering by the way. My
Is that right?
apologies. Yeah, I'm
Okay,
not
no,
a big
that's
because I started my career as a data guy like more than
right,
20 years. So I never got a chance to go into software engineering. And
right.
I always clash people on software engineering. I do not know why. Because when we are recording, we are online. Let me say loudly. For me,
Okay.
software engineering normally try to get things done very quickly, which we want now. Yes, true. But foundations are not properly looked into it. That's my only disagreement in software engineering, right?
So is that your experience and your teams you've talked to about software engineering? Because software engineering is completely about foundations, about good engineering. The engineering, I mean, you could argue whether it's real engineering or not, but yeah, I mean, I've built many transactional systems after 30 years. I have all that stuff in it. My solution
So
architecture documents
transition.
always have that stuff in it. So they're called non-functional requirements, security, resilience.
No, no, no,
I
no, no.
think so. Software it's been doing this for 30 years. So that is absolutely all that. It sounds like, Mr. You've been encountering some not so great software
Okay.
engineering teams. Yeah.
Let me refine my question, narrow down my question.
Go
When you
on.
talk about application, which is OLTP applications, software
Mm.
engineering for me still works over there, and that is what software engineering is. But once you come into a OLAP world, taking out data and do this whole thingy, which we both agree that there should not be so many layers, it should not be 3 months process. Once you come into a OLAP world, that is where I have a disagreement with a lot of software engineering folks that do it the same way we create OLTP.
Right.
That
Okay.
is
So that I get. That so it's not software engineering because data work is software engineering. I hate to break it to you, but it covers in the same thing. It's a particular branch of software engineering. You're building data pipelines. That's software. You're delivering software. So it is. I understand the traditional way of building data warehousing. And let's be clear, this is the data warehousing kind of approach. This is what's all kind of grown out from. So the landing, the software, this kind of stuff. Using the way you're doing software engineering, I understand it's quite different if you're doing microservices or if you're monolithic or you're building object models and class models. That's not as appropriate inside, or traditionally not been appropriate into that way of working. The interesting thing is, there's two. I'll challenge that too. One, I'm actually doing exactly that. My process is merging those two things together fundamentally, it's compressing the stack
agreed.
fundamentally. And secondly, in the AI world, there's no OLTP and online and OLAP worlds. They are together. My credit process does a number of those things. It creates a report. There's no there's no OLAP. It creates a machine learning model. It also does decision model, which is transaction. So the new world is basically we have steps which are OLTP type steps, and there are steps which are OLAP type step or analytical processing type step, and we have a whole bunch of other ones. Machine learning isn't OLAP, right? It's not. It's Not in that sort of terms, right? It's an analytical model. It's not necessarily in terms of that kind of,
If you ask
so
me, machine learning comes into the OLAP world for me, not
not
OLTP.
the approach, so not kind of
Not the approach, not the approach.
yeah,
The
exactly right,
ecosystem.
sir.
See,
Yeah,
when we
exactly right,
see if we go
exactly
to
right.
really deep of OLAP, OLAP is
Yeah,
normally denormalized queue concept, right? If you really go into deep, but people don't understand that. So now I just categorize OLTP and OLAP.
yeah,
Data
indeed.
preparation, staging, these are not OLAPs. OLAPs are specifically cubes. When
All
you
right. Yes. Yeah. Exactly right. Yeah. So
that's
I say.
what OLAP was.
Absolutely. Well, there's also star schemas and polymer databases, and that was still so you have MOLAP and ROLAP and the different
Yeah,
hybrid
MOLAP,
stuff. But
OLAP, yeah,
yeah,
all
yeah, but
are there. Yes.
all that kind of stuff. Yeah, exactly. But that's what I'm saying. Now you have end-to-end processes which have analytical steps and transactional steps. Let's call them those analytical steps and transactional steps, and
Yeah.
they're part of the same business process. I might have a small component that does an analytical model. I have a sort of process that actually books an order or something after that one. And this is the compression. So the transactional world and the analytical world, and I said this about 5 6 years ago on the Data Mesh Learning Slack channel, they're merging, right? These are artificial barriers now. You have different workloads, and they're only really built around the point is around reporting teams. We have data teams which are largely like would have been reporting teams 5 10 years ago. Now we have agents and AI doing end-to-end business process. So do we need to rethink that kind of analytical versus transactional organization model to actually think now we're implementing when we have people who are experts in transactional processing models and also analytical processing models. Data scientists are very much the analytical, software developers are very much the transactional, and we build, cohesive ecosystems of these steps together. This is the microservices. This is what service-oriented architecture was 20 years ago. This was the vision around it. We have services which are both, and they're orchestrated together in a graph. Funnily enough, so we're kind of going full circle. This is what agents are doing. Agents are doing all this anyway. They're doing analytical models, they're doing analytical transactional models, they're booking stuff, they're calculating, they're analyzing, they're doing this kind of stuff. So we now come literally, funnily enough, it feels like deja vu 25 years ago when we started doing service-oriented architecture. We're now back in the same sort of world because agents are orchestrating the whole thing together, doing different types of process.
We have a time check. A few minutes. I can talk hours and hours. It's right. Yeah. So I think it was a great discussion, and we both are from data world, and we can talk day and
Yeah,
night onto it. And I'm happy to hear that you are from software engineering side. So I think we should have another session and we start debate on this because
definitely. Yes.
I'm still on not the same page that see again I always again I say ground reality is also you have to look into it
Yeah.
because
Agreed.
I was
Agreed.
also a consultant for around 18 odd years. Then last 7 years I was a customer end
Yeah.
on the other
Yeah.
side of the table. That is where I
Indeed.
realized ground reality at a customer end little bit different. There are
Yeah.
risks you have to take care. There are
Totally.
skill sets you have to take care. There are compliance
Yeah.
you have to take care. Cyber security another issue. So once you look into that piece as well, so ground reality changes. Yes, it is very ideal that let agent do everything, right? But can that happen? At today point in time, question mark, I would say.
Yeah. Yeah. Yeah.
Yes,
No, agreed.
for,
Agreed.
for certain non-compliant domains, maybe yes. But the moment you come into telco, you come into health industry, you come into banking industry, I think it will still take time when a lot of good use cases being implemented using agents.
Yeah.
Maybe few years past, success stories, then maybe these industries start coming towards that. So yeah, I think it was a great session. I really understand where you come from and your
Yeah.
product is, and you guys are on my list where wherever I go and talk, just like we just talked about Shane, we just talked about Nicholas. So I do
Yeah.
talk about your product as well. And looking forward someday we can work together.
Definitely.
At least we end up creating some PVP. I don't want to call it MVP. I want to promote my own PVP.
No, indeed,
Yeah,
indeed. No, so
yeah.
yeah, thank you, Mr. Well, I think, I mean, for me, just one or two takeaways would be at the moment it's agents everything. It's not agents everything. Agent is part of one component of the ecosystem. this is what's happening. But it is end to end. It is business use case. It's not just the data world. We're merging those two things together. And there's a lot of thought and experience and all the stuff you just talked about, how we convert all those requirements into something that's agile. And that's basically what we're doing. So, but it is like, it's 20, 30 years worth of thought. You don't do it overnight, and you don't do it just with an open source library, right? So you're absolutely right. You can't throw an agent at it and get it straight to work. You've got to build the whole kind of the ecosystem. You've got to make the whole ecosystem agile and end to end. But thank you
I
so
know,
much for this conversation. It's awesome.
I know we are 2 minutes on top, but let me market you a little bit as well in a minute or so. When you do that, can you tell our audience, whoever is listening, do you have a license? This product is licensed. If it is yes, what is your model? Is a transaction based, it's a CPU based, it's a user based, how you do it? Or secondly, your professional services. Normally each use case, how much time it takes.
So we are actually a hybrid model. We're a bit like the Palantir model, where we'll come in and help you build an end-to-end use case and then leave you with the software, which is basically a consumption model per data product per virtual CPU. But the typical use cases, we can do use cases in like 3 or 4 days, fundamentally, 2 to 3 weeks, that sort of thing. POC, I've done a number of POCs in 2 days, fundamentally, with clients' actual real data. I got to show it out. Sometimes it proves value, sometimes it doesn't. You can actually spend a very little money to be able to do that. But an end-to-end use case can take days to weeks.
So you use your own environment or you use customers' environment?
Customers always deploy it locally into cloud, on-prem, edge, anywhere. It doesn't matter. Yeah, well, if they can Docker container, we can deploy it. So yeah.
Awesome. Okay. Thank you, John. Have a nice
No
day.
worries.
Pleasure to have you. It's always pleasure to talk to someone who I can really learn. Actually, I meet a lot of people. I always end up learning. Just met this guy, Robert Mark from US. He has come up with this universal, interoperable data sets. Awesome. He's
Oh yes, I saw that. Yeah,
Yeah, he's trying to get rid of MDM solutions. MDM's $1 million, right?
yeah.
If his product end up working, I think we have a planned demo with him in a couple of months, right?
We do indeed. Yes, yes, absolutely, absolutely. Well, so yes, yeah.
See,
And
people are doing super good.
exactly. But this is the same point, right? We're trying to crack. We're trying to compress down the traditional ways of doing stuff, right, in data, because we've been doing them for 20, 30 years, and AI is disrupting it now. So it's right to be able to have that kind of conversation. I think.
I end up loving my own podcast because I end up meeting so many people, and these are innovators. Someone is sitting in New Zealand, you are in UK, this guy is in US, another is sitting
Yeah,
in Italy. Francesco Pepini is sitting somewhere, and so many innovators, they're unable to connect somehow. But never mind. Thank you.
that's brilliant.
Have a nice weekend.
You too. Thanks, Mr. Thanks, really appreciate being on the podcast. Catch
Pleasure.
you later. Cheers.
Bye
Bye.
bye.